So now that you've hopefully run your first Python program, if you haven't, please go back and make sure that your PyCharm has been installed. And if you're not able to, please don't hesitate to reach out with questions. We have currently only written a very, very small program using the print function. And so now the time is to start learning how we can build Python programs that do more interesting things. And the first step on that journey is with Python variables. If you recall from an earlier course overview, there are 7 basics of computer programming. And these 7 basics, when combined, can be used to write any program that's ever been written. Today we're going to study the first of these, variables. And if you can see to the right, we have some pseudocode examples of 2 variables, x and hello there. Every variable consists of a couple different components. So first is its name. In this case, we see 2 variables, x and hello there. That's what the variables' names are. It's to the left of the equal sign. To the right-hand side, we see the values of these variables, 5 and howdy in quotation marks. And these values get assigned to our variables whose names are on the left of the equal sign. So the values are on the right of the equal sign. The names are on the left. In addition to names and values, all of the values of variables also have a type that's associated with them. So the type of value that it is. So for example, Python is going to handle text data differently than it's going to handle numbers. So let's start looking into what those data types are. In Python, there's 3 different ways that we can represent numeric data. Integers, which are whole numbers, or ints, floats, which are real numbers containing decimal points, and complex numbers. These are imaginary numbers, if you've come across that in math class or physics, and we won't deal with them very much in this course outside of understanding and recognizing the type. And if you can see to the right, complex numbers have J's in them, which makes them a little bit different and distinct from the ints and the floats. Now, one thing to consider in storing numbers on a computer is that the type of data that we make a number can influence the size of the number or how many significant digits we can represent, so how small or precise for the number. Because a computer actually cannot represent all possible values for every number that exists. Partly that's because numbers are infinite. And I don't know about you, but my computer only has so much RAM, or so much memory. So our memory has finite capacity and numbers can be infinite. So eventually we're going to reach a cutoff point that's going to limit the number of significant digits or the precision of the values. So for example, on the bottom of your screen you can see pi 3.14159.265. Pi has more decimals, but we're out of space. And so we actually can't store more than that. Or we could store more than that, but then we can't store other things. So when we're dealing with infinite numbers and real numbers in computer programming, we have to be cognizant of the fact of exactly how much we actually need to store because we can't store the entire number. As an example, what happens with this is because of the lack of precision, sometimes we get errors. So if you were to type in your Python program, if you were to print 0.1 plus 0.1 plus 0.1, it would print 0.304. It's not going to print 0.3 because there's slight imprecisions in how numbers are internally represented. So we always have to be cognizant of how much precision we want. Another data type is string, and that's to represent textual information. So strings, you can recognize them because they're in double quotes or single quotes. For example, hello world, see, that's Buddy's dog. If you want to include single quotes in your string, you want to put that inside of a double quote or vice versa. So for example, if you want to have double quotes in your string, have single quotes be how you indicate the string on the outside. In addition to numbers and strings, we also have a concept of a Boolean, and this mirrors and aligns with the concept of binary digits and bits that we had talked about earlier. So a Boolean can have 2 values, true and false. And we'll talk more about Booleans when we get into conditions later on. So take a moment and try and think about what each of these values type is. So I'll give you a moment to jot those down and then we'll discuss them. Okay, so did you take that moment to jot down what each of these types are? Awesome. Okay, so 52 is a whole number without a decimal point. It's an integer. Negative 0.01 is a float. 5.0 has a decimal point, and yet it's a whole number. It's still a float. So that decimal point is really what indicates that something's a float. 4 plus 6j, that j is that key thing you want to look for. That's a complex. 3.7 looks like a float. Aha! But it's got double quotes, which means it's still a string. So strings can represent text or they can represent numbers. But the key thing is that when a number is in a string, it's treated as if it's some kind of a text. 4047583648 is a whole number. It's a large integer. True with a capital T is a Boolean. False with a capital F is also Boolean. And finally, we have false with a lowercase f. That's one clue that indicates this is not a Boolean value. And it's in single quotes, which is the real kicker. It means it's a string. So now that we've thought about the types of variables, the next step in creating a variable is also understanding how we should name them. So variables are what we use in programs to save data and information in memory. Variables have names, which are also called identifiers. An identifier can be any word that consists of letters, numbers, or underscore. It cannot start with a number, and it can't be a word already in use in the Python language. It can't be a Python reserved word. So for example, for, while, and def are keywords that we'll use to write our Python programs. We can't make variables that consist only of those names. You could create a variable called for2 or while 5, but it can't just be FOR or WHILE. Python is also case sensitive, which means the lowercase variable name change is distinct and different from change with an uppercase C as a variable name. Now, the Python interpreter doesn't care how we name our variables, but humans usually do. I don't know about you, but I like to read the programs that I've written, not just write them. So in general, we want to follow some conventions. Variable names should start with a lowercase letter. Constants, that values that won't change, like pi, those should be in all caps. And let's think of an example. So a variable for the current year. This could possibly be considered as a constant, or it could be used as a variable depending on the program. Some likely candidates would be current year, current year, current year, and current year and current year. Now, some of these are not good names. Can you figure out which ones? So the last two are not good names. Current year, all lowercase, all together, is difficult for a human to read, and ostensibly, that's kind of the point of variable names. Current space year is also an invalid name because you can't have spaces in identifier names. Current year with the uppercase Y is known as camel casing because the Y looks like a hump in the word. That's fine. It helps a human see the differences between the words. Current underscore year is called snake case. It looks like a slithering snake a little bit. And so the underscore separates the words. And current year all in caps with an underscore is also acceptable and would frequently be used if current year was a constant. So coming up with representative variable names is really significantly important. It helps us remember what the variable represents and what its value is contained within it. And it's also easier for others to understand your program. So for example, if I was going to represent information about a person's first name, then I might call the variables first name or first name. If I want to represent the radius of a circle, I'd call it radius rather than just simply r. And if someone is employed or not, I would name it isEmployed. Imagine if that is wasn't there and I just named the variable employed. Well, if I just named the variable employed, it might be difficult to know what true and false mean. Does True meaning the person is employed or not employed. So by putting the is in there and asking a question for Boolean variable names, it helps me understand the semantics, the meaning of the value that the variable is storing. So in general, good variable names are related to the values that they store. So let's put this all together. Take a moment and think about representing the information in the leftmost column: a person's salary, sales tax, if the item is taxable, the course name, gender, and the graduation year. What data type do you think would be represented? And then try to give it a name. Try and see if you can think of a reasonable variable name for it. I'll give you a minute to do that before we discuss. Okay, did you take that moment and pause the video and try and take your own stab at the data types and the variable names? Great. So a person's salary could be an integer, could be a float, especially if someone is getting paid an hourly wage, which arguably isn't a salary, but their salary might have decimals, might have cents in it, and I might name that reasonably salary. To represent sales tax, though, it's definitely going to be a float because sales tax is usually a percentage, so it's a value between 0 and 1. One name for that might be sales tax. When it comes to variable names, there are many different possible names, and so there's a lot of possible correct answers here. As long as you don't have a space in your name and you don't keep everything lowercase if it's more than one word, you're probably safe. But if you have any questions, that would be something that would be great to bring up in the discussion section of the course. If an item is taxable, that's asking whether something is taxable or not. That's a hint that it's a Boolean. A possible name could be is taxable, which clearly indicates what the values of true and false mean. If is taxable is true, it's taxable. If is taxable is false, it's not. A course name is usually a string. Usually it has letters, could have numbers in it as well. One possible name for it could be course underscore name. Gender is a little bit more interesting. Gender is likely male or female, and it could either be string or Boolean, because technically gender is only trying to represent two values. And so true or false could be mapped or encoded to be male or female. However, the name might change depending on the type of value that we're holding. If it's a string, I think gender would be a perfectly fine name. However, if it's Boolean, you have to name it differently. If it's Boolean, and you named it gender, what does true and false mean? Is true male or true female? We wouldn't know. So if I'm going to create a variable, a Boolean variable to hold gender, then I would make the name of it answer the question of what does true and false mean. So is male clearly indicates that true means someone is male and false means someone is female. Lastly, we have the graduation year. This one can be a little bit ambiguous. Should it be treated as a string or an integer? I can see both cases being used, although we've indicated just integer here in the chart. A likely variable name could be grad year. And again, these are all just suggestions of names. There's infinitely many possibilities that can contain meaning. So once we've created our variables and we understand their types, how do we actually get the values in the variables? We do that with what's called the assignment statement in Python. The syntax is a variable name equals some expression, and this mathematical expression is calculated and computed, and then the resulting value is what gets stored in the variable's name in memory. The semantics of the assignment statement of the equal sign is that the variable is set to the value of expression. After a variable is set to a value, it's said to be initialized. Some examples include month equals 1, important number equals 4.5, or month name equals January, which would be a string. One common misconception is that these are not equations. You should not be reading equals the same way you might read equals in algebra class. It doesn't mean that the two sides are equivalent. What it means is that whatever is on the right-hand side of the equal sign is getting pushed into the variable name on the left. Let's take a look at this and what it means for computer memory. You can think of computer memory kind of like a bunch of post office boxes all in a row. And we can shove letters or values of data into those post office boxes. So let's say we have a Python program that consists of two simple statements, x equals 5 and y equals x. The statements are executed in order from top to bottom, and the value of x doesn't change because of the second assignment statement. So what happens here? Well, first, the computer gets the value 5 stored in it, and then we end up with a pointer of x to the value 5 in memory. So the variable x refers to this slot in memory, which currently contains 5. Now let's go on to the second statement, y equals x. Well, first, Python does a lookup in memory to find the value of x. So it goes to memory, it goes to that x, that follows that arrow until it sees 5, and then it makes a copy of that value in another spot of memory. And then it creates the pointer of the name y to the value in memory of 5. So for some guidelines, only the variables to the left of the equal sign for the current statement change. We'll usually only have one variable on the left. We want to make sure that we initialize any variables before using them on the right-hand side of a statement. So you should never see a variable on the right-hand side of an equal sign if it wasn't on the left-hand side somewhere earlier in the program. In addition to calculations and computations for our variables, other values we can use include literals. A literal value is any value that you can see in the program itself. So for example, for 3.2, the strings Q and books. Those are literal values, whether it's a literal number or a literal string, you can see its value. So in a program, all data is either variables or literals.